Hello again, my name is Ben Canning, and this micro lecture is on Newton's second law. As always, you need 3 or more bullet points worth of notes, 1 to 2 sentence summary, and to do your follow-up questions on Google Forms. Alright, Newton's second law says the following. The net force acting on an object is going to be proportional to its acceleration. That is, net force is going to be equal to mass times acceleration. Here we're going to mostly be using net force in for where we plug in for force. The reason why is because it's net forces, or the overall or resultant force, that causes the acceleration, because any individual force can be partially or fully canceled. There might be other forces acting on it. The units for force are going to be newtons, just like they were for weight. A newton is the same thing as a kilogram times a meter per second squared. So in this case, we know that the units for mass are kilograms, the units for acceleration are meter per second squared. So that gives us this unit of kilogram meter per second squared. That's a mouthful to say, so we just abbreviated that as 1 newton. Now, one thing to note is that this follows the same pattern as weight. That's because weight is a force, so we can see that mass is plugged in, and here instead of acceleration, we're using g, which is actually just the acceleration due to gravity. In this case, it's 9.8 meters per second squared, or about 10 meters per second squared. So it's a specific acceleration in this case. Now, like I mentioned before, there's a linear relationship between net force and acceleration, or proportional to be more specific. So if we were to graph this, we could plug in different accelerations and see the resultant force or net force required to cause that acceleration, and we would get a linear relationship. Now, the relationship between mass and acceleration is a different one. So force and acceleration was linear or proportional, but the relationship between mass and acceleration is one that's inverse. We can see this based on if we kept this force constant, let's say 10, then as mass increased, the acceleration would have to decrease in order for the net force to still be 10. So if we go ahead and isolate mass away from acceleration, we can see that acceleration and mass have an inverse relationship. That is, it mimics y equals 1 over x. If we were to graph it, it might look something like this, where the steepness of the curve is based on the value of the mass, the value of the force. That's it for this one. 3 or more bullet points worth of notes, a 1 to 2 sentence summary, and please do your follow-up questions on Google Forms.